Hello, everyone. Sorry for the late arrival. Welcome to today's webinar, How DCI to the Edge Will Be Important for AI. My name is Greg Tishless. I'm the marketing manager at Ribbon, and I appreciate you joining us here for the webinar on the Bright Talk Network. Today, we're led by two of our experts who will be talking today about data center interconnect, the edge, and the impact of AI. First, we have Mitch Simcoe, our expert in IP and optical solutions, and Philippe Correa, our senior solutions architect. Before we get started, I want to point out the Ask a Question section, which is located just below the slides that Philippe and Mitch will be sharing. You might have to scroll down a bit to see that feature, depending on your screen view. Please ask us any questions that you might have. We love hearing from you all throughout the webinar, and we'll monitor those questions, and we'll circle back at the end for some Q&A. And that's all I have for now, so I'm going to turn things over to Mitch, who will get us started. So, Mitch, it's all yours.
So thanks so much, Greg, and good morning, good afternoon, everyone. Thanks for joining our webinar today. I think you're going to find some interesting content. We're going to talk about, obviously, the big hot topic continues to be around AI. We're going to focus on the role that the edge plays for delivering AI services and how DCI is going to be important to the edge as well. So lots of interesting stuff to come. I'm going to cover kind of the first half, and I'm going to turn it over to Philippe to cover the second half of our presentation. So the first thing I'll talk about, no big surprise about the role of AI going on in the market today. I mean, since ChatGPT was introduced, and it's hard to believe it was like the end of 2022, we first came to the world. People got to see the power of what AI could do. But the reality is there's really no industry that hasn't been touched by the role of AI. The role I play in Ribbon is in marketing, and we can see so many different ways AI can help us. I know in my day-to-day job, I do a lot of writing, and it just never ceases to amaze me to see what AI can do to help, craft content, actually can review my content. It was a feature I just realized. You could have written something and AI can take a look at it and act as an editor to really improve it. So it's just, in certain roles in marketing, it's been very powerful. This chart I just kind of show many of the industries, the roles that the industries have been looking at AI. Everyone's been trying to look at how to use it. Where are the ones that have seen the best return on investment? You can see kind of the little green bubbles, as we mentioned, marketing, supply chain, IT, and cybersecurity, interesting enough. Lots of things where AI is going to help there. IT, I know many companies have basically said, a vast majority of their coding is going to get to be done by AI. So just tremendous things that just continue to happen. I think the role now is companies are really trying to see, how do I monetize it? So it's not just about cost savings, but how do I make money at it is really the main thing the industry is really trying to grapple with. That's really going to take off. I think AI is those of us who've been around long enough can remember the dot-com era around 2000. That was really the first kind of inflection point, from the internet. We saw everything the internet did. AI is viewed right now as kind of that next inflection point where we're going to see such tremendous, improvement in productivity. And I think we're just still at the cusp of seeing what that's going to deliver. Now, just in terms of, we're all in the networking area. What does that mean what does that mean in the impact on the network? So the first thing, starting on the left, is to enable AI, the data center operators, the hyperscalers have had to build these huge GPU clusters. And I don't know if you know the history. The leader in that, we certainly all hear them on the news, is NVIDIA. I don't know if you know the history, how they started. Basically, if you go back 10 years, 15 years, they were really a graphics card company. They need GPUs, which were really to accelerate the performance of playing video games. And if you look at what are you doing to do a graphics card? Well, you are trying to predict, when you're painting a screen 30 times or 60 times a second, you're trying to basically predict what is that next pixel of that frame going to be. And so the techniques to do graphics cards really, NVIDIA discovered, well, we could use that for AI, because really AI is really the same thing. It's about uncovering patterns in data. And the more data you give it, the better the model gets. So many companies have built out these GPU clusters within data centers. And the first kind of instance from a network perspective is we needed to interconnect those clusters. And so that's where optical components, which are really big, 400 gig, moving to 800 gig and higher connections within the data center. So we've seen the result of that is that the amount of spend for optical components inside the data center doubled from 2023 to 2024 to almost $11 billion a year. So just tremendous growth in that area. You know, let's face it, we don't see growth like that in the telecom area, you know, very often. Now, they can only build these these GPU clusters so big, right? Because they huge consumers of power and cooling, and so they basically exhaust how big a data center can be. So ultimately, you have to build more data centers, and you need to interconnect them. That's where DCI comes in. And the format, the most common format of optical equipment to interconnect data centers is called the compact modular, which is kind of the pizza box format we're all familiar with. Well, that, the analysts are saying, is expected to grow to represent almost 35 to 40% of the total optical transport market will be in this compact modular format, showing that DCI is going to continue to grow as a percentage, even though the overall market for optical transport probably is going to grow at a pretty small rate. So it really shows the market. The market is there, certainly inside the data center and also outside the data center. And that's really where we're going to talk about the impact of this from a network perspective. So let's talk about the term AI training versus inference. And I think this is something, if you're kind of even moderately familiar with AI, you'll hear these two terms, right? And these are kind of the two main ways of basically building out a AI model. You may hear the term large language model, and then using the model, which is called inference. So I have to train the model. So training the model means taking basically labeled data. So the examples we give here, like a picture of a strawberry, a person, a bicycle, and you're basically training the model to identify those patterns. It could be an image, looking at the pixels of what makes up a strawberry, and basically feeding it. And the model basically learns, the more data you feed it, learns that, oh, if I see a strawberry or I see a bicycle, that's what that means, right? And there's so many ways that they're developing these models for all kinds of things. So that typically happens in a core data center. These are the big Walmart-sized data centers, typically in the main hubs where these models are trained, where they've got the GPUs and the compute to be able to train these models. So you need DCI to feed the model. You need to feed it lots of data to create the model. But once the model has been created, there's only infrequent updates to it. You're going to continue to update and refine the model, but the big data is kind of at the beginning of training the model. The bigger opportunity is going to be in inference. Inference really is using the model. So that's where, whether you're using ChatGPT or every single Microsoft Copilot or whatever, that's where the model has been created, and that's where you're using the model. So typically those models, you want to deploy those models as close to the user as possible to be able to get the best performance for your AI, whatever AI function you're doing. And these will tend to be done at the edge of the network, closer to the user. So here an example of inference is you give it an image of a bicycle. The model is able to, based on the model that it's been trained, to say, that means it's a bicycle. And that's the example of inference. So that's why the edge is so much more important, because you're going to see the edge will be exploited. In the end of the day, AI will be much more about inference than it will be about training. Let's just map this a little bit into the physical world. And I kind of look at this analogy. Imagine the early days of Amazon, right? So Amazon was primarily a seller of books. They may have had one big warehouse, say in Seattle. So if you ordered over the internet a book from Amazon, chances are it was shipped directly from the main warehouse in Seattle. And when you're just starting your business, that makes sense because you've got to start somewhere. So the issue here is that the shipping times are going to get long because your inventory is all in one spot. So easy to manage your inventory, but from your customer perspective to scale your business, not the best because you're going to get long shipping times. But look at Amazon today. What they've done is say, I want to maximize the delivery time for my customers. So what I'm going to do is introduce edge warehouses. I'm going to put warehouses stocking the inventory of my most commonly used items closer to where my customers are. And I'll manage that inventory. So now when someone orders something, chances are it'll get shipped from your local Amazon distribution site. I'm here in Atlanta and we've got tons of these sites. I happen to have one maybe 10 minutes away. So I get great Amazon delivery times. That's really where the model. So if you think of these in the physical world, these big distribution centers you see locally are kind of like your edge data center. So what's in the physical world really does apply in the virtual world as well, because it's really no different. If imagine this being an AI model, again, you don't want to have to go back to Seattle to do your inference. You want to be able to do it as close to you as possible to get the best performance. So where is these edge data centers? And so really, and I've kind of looked at this over the last number of years, and some analysts have tried to, pigeonhole this. They look at this as there's a near edge, there's a far edge. They try to really categorize this. But at the end of the day, I look at the edge being anywhere to meet the application performance, such as latency, for whatever application you're doing, whether it's AI or some other application. A common application we've seen in the past, you remember those the Apple Vision Pro kind of virtual reality goggles? Well, the application to run that, you would want that to be as close to you as possible, because otherwise, if the latency is too high, you're going to get blurry vision. It's not, the application won't work. And it's the same for AI, right? For you to get the performance that we all are kind of starting to rely on from using it on your iPhone or your iPad or whatever, again, you want that to be as close to you as possible, whether you're a mobile, residential, or business user. So the edge can be anywhere. And again, you're going to see some edge locations close to the user. We're going to talk about how telco central offices could play a really good role there. You'll see other edge offices a little bit further away, maybe in a metro hub. End of the day, it doesn't really matter. It's anywhere where it meets that application performance. Now, where will these data centers be deployed? So as I mentioned to you, kind of the first generation, and this kind of comes out of the first generation of the internet. The initial data centers for the internet were in these big hub markets, kind of the ones in black on this map, right? So the Ashburn, Virginias, the Chicago, the Dallas, the Bay Area, the Seattle area, and Phoenix is a big one as being a backup for the Bay Area. Right? These were the big hubs where you've got hundreds of data centers clustered in a metro. What's happening is that the power and real estate cost of expanding those locations is becoming onerous. So now when people are looking at building the next set of data centers, especially when it looks to AI, because they're so power hungry, they're now locating them in places where the real estate is cheaper and where the power is accessible. So examples of this, some interesting markets you may not be aware of, things like Omaha, Nebraska, Des Moines, Iowa. Again, in the middle of cornfields where they've got lots of cheap land, they have ability to deliver power. We're starting to see lots of growth in data centers. Where I am in the Atlanta area, we're starting to see a big growth circled around Atlanta. Again, here in Atlanta, here in Georgia, we just turned up the first nuclear plant in the last 35 years, the Vogtle nuclear plant. So we're starting to see new data centers tapping into that energy. So lots of new markets. Again, don't think of the traditional markets. We're seeing the growth is going to be out really anywhere we can get the land and especially power to power all these new AI applications. And so my last chart before I turn it over to Philippe is really looking at who are the ecosystem players for AI and how does this play to the edge. So if we look at the first generation, the hyperscalers, which I mean the Facebooks, the Googles, the Microsofts, they again started from the core, right? They're again building these training models in the core of their networks where they can get these GPUs located. Now they know they have to move closer to the edge to get the better performance, right? They know they can't scale doing everything in the core. Now they've tapped into folks like the data center operators who would be like the Equinixes, the Digital Realties. These are folks that have built out data centers in more metro edge locations, again, to appeal to sell to hyperscalers, to enterprises. Now, I think the service providers are coming from a different angle. They have thousands of central offices they've built out over decades to support voice and data services. And they're basically trying to partner with the hyperscalers and the data center operators to provide what I call very valuable beachfront real estate, because it happens to be right in the right location, which is going to be needed for the good performance for AI, whether it's a mobile, residential, or a business customer. And so it's going to be very interesting to see the role. I think our telco customers really are sitting on some valuable real estate that they can leverage. And we'll talk about this in terms of they're modernizing, freeing up lots of space that can be leveraged to do AI inference. So I'm going to turn it over now to Philippe, who's going to kind of continue and double click on that topic. So over to you, Philippe.
Thank you, Mitch. Appreciate that. Good day, everyone. Now, continuing that, right, with regards to the classic service providers there and those central offices, and talking to many of the tier ones, many of the tier twos, including tier three service providers, there's been three key roles, right, in our opinion, that's been coming up for providing that edge AI capability or leveraging edge AI at these particular offices. But there are three key roles for classic central offices, right? One being infrastructure. Two, data center fabric and distributed AI. Now, with infrastructure, right, as you heard, obviously this build out of data centers, this real estate grab that's been going on, great, right? Obviously based on power needs or a lot of different things that are driving that. But the central offices, what they've got today is that infrastructure. They've got power, space, real estate space. They've got obviously cooling capabilities that are there. They've got, of course, more importantly, the fiber infrastructure, right? Which we'll talk about a little bit more. Not only north-south or meaning, being able to connect back to key peering points, but also southbound to all of those particular consumers, right? Business consumers, residential consumers, as well as carrier neutral capabilities there, right? Carrier to carrier, right? And one thing, as we note here to stress out, right? We talk about these major data centers that have been going on, that are building out, that are requiring hundreds of megawatts to gigawatts of power. The power demand as we're distributing out further out isn't as high, right? So I wanted to stress that key point. The amount of resources that are needed for these distributed central offices isn't the same, right? So we don't require that level of power demand as these major data center build-outs that have been going on over the last couple of years. The other thing that I highlighted there just briefly was the meet me, right? That classic meet me point. Thanks to deregulations, right, with regards to ILEC, CLECs and the capabilities there, the infrastructure has been put in place to provide easier connectivity, not only obviously to that end consumer and that provider network and back peering locations, but also to other carriers, right? Other infrastructure providing or other data center solutions that are nearby, right? So a classic meet me point has been established for decades now. The fabric aspect of this, right? The second key role here, as you look at these data centers, you look at a classic data center or a classic major data center campus of today, right? It is basically a build out of multiple offices or buildings, right? So as you look at these central offices that have been distributed across communities, right, across these different locations, provide you a new type of data center fabric, in a way like a breakdown of each pod, right, at all of these data center or building or CO locations. And we'll talk about that in a little bit more. But one of the key points in thinking about it, right, as we distribute these functions or these applications relevant to AI, is being very surgical on where in placing the particular function, right? There could be, based on demographics, based on businesses, there could be certain key applications that are put into these certain central offices. Just like any other data center campus, there could be strategic areas with regards to storage array networks. There could be strategic areas for certain business, warehouse, enterprise company locations where we want to identify a particular office for those type of resources, while also providing a fabric for high availability if necessary. Okay. On the distributed AI, this is nothing new, right? With regards to data centers, you heard Mitch talk about companies a la Equinix, Digital Realty, or all these companies that have built out massive data centers, similar to the whole Amazon build out infrastructure, right? You've gone out to the major cities as well, the major metro areas they've built out campuses. But as mentioned, now we're talking about distributing this a little bit further. And so distributing these resources, right? A distribution of resources. I don't need the massive amounts of resources centralized in those metro areas as I used to. I can now distribute those in a surgical manner across these offices, thousands of offices if necessary, right? I look at it similar to when mobile networks are built out, right? You look at these classic topologies that are there, from a macro cell to microcell to picocell capability, right? In increasing that proximity to the end users or end businesses, right? There are thousands of these offices as the different providers were telling us, right? But as you think further ahead, be that surgical capability, but these thousands of offices also have millions of telephone poles, right? There are already compute resources at these small cell locations or picocell locations, right? There are compute capabilities that are there. So you can understand that as we get a little bit more surgical, or the business case becomes surgical for that type of capability, you could take advantage of more of that footprint across, right, as necessary. So again, 3 key roles there that we're seeing based on these discussions. Next slide, Mitch. Now, how do we help realize this type of infrastructure build out? All right, so I'm showing a classic view here of, as you look at these central offices that are built decades ago, we're talking about copper facilities, right? We're talking about massive build-outs, massive offices as well, right? Large offices, even in smaller towns, large offices that were built to house that legacy networking and voice infrastructure. Your whole voice PSTN infrastructure that was built out for these local exchanges that were there. So bigger buildings, racks of equipment that were built out, and obviously some classic network infrastructure. Now, companies like Ribbon are in a unique position to help these central offices realize the opportunity of hosting a data center, right? As you can see, I'm showing an actual example, right, of a particular customer that had 22 different sites. And if you look at it, they were able to modernize that voice infrastructure from, in this case, 14 racks down to 1 rack with new voice infrastructure. Same thing with regards to network infrastructure, right? That legacy voice infrastructure is anchored to legacy networking infrastructure, right? So you're looking at this evolution of elimination of copper, still maintaining the resources that you need for those voice services, freeing up space, freeing up power, right, for more racks of compute space at this point. So again, this is a classic example here. There are many examples that have been going on in companies that, like as Ribbon, can not only provide obviously the voice infrastructure components of it to modernize that equipment, but also the bridging solutions to still maintain the legacy connectivity, the TDM, SONET infrastructure that's still out there that we need a bridge for circuit emulation, but then evolving to a modernized network infrastructure, right? Modernized, higher density packet-based solutions. So companies like a Ribbon can provide that role of freeing up that space and providing the power capabilities that are there. Mitch, I'm sorry, can you go to the next slide now? Now to that point that I was making a little while ago with regards to a fabric, right? A data center fabric. As we know, within a data center today, based on distribution or hierarchical distribution of networking, you have pods that are built out, your classic leaf spine architecture, aggregating this information, providing simple network connectivity, right? And then within some of the more, let's say, modern day data centers that are coming in or campuses that are coming in, you'll see that they're not only from a pod standpoint and looking at the compute hierarchy and resources and aggregation of those flows, but also now a distribution of buildings, right? And high connectivity between these buildings in a campus. Each of these buildings may have different roles. There could be storage array networks, right? There could be specific applications that are customer focused, right, on the size and demand and the resourcing need. Well, now as you look at these offices or central offices at the edge, they become a data center fabric, right? As I mentioned, right, we can be very surgical now, or the consumer or the function developer, right, that particular AI application that's there could be very focused on a particular area where 80% of this particular area could be very relevant to that business application. Now, there still may be a need of obviously 20 to 30% of other users or businesses accessing that, right? So you need that fabric connectivity between there. But you also look at high availability as well, right? As things may happen at a particular office or a function may fail, you need to have the ability to move over these functions and applications to another CO or data center in that vicinity, right? So distribution, diversity, high availability of resources across these central offices / data centers. So you look at a bigger view of these DC fabrics spread across the different central offices in that particular area. The other thing to keep in mind here, as I look at this, right, and look at this infrastructure, and I'll talk about this in a little bit, the traffic congestion, right, the amount of demand that I may now have between these offices may increase. So you may see, obviously, line systems or ROADMs or mini line systems play a bigger role in taking advantage of that either ring infrastructure that's already laid out. As I said, the biggest part of all of this is the fiber infrastructure. So there already may be fiber rings already laid out, or these could be hub and spoke type of implementations. But I may need to take advantage of an increasing how many fibers do I have connecting these offices? And if limited, how can I make most of these lower density fiber connectivity areas, right? And leveraging line systems to do that, or ROADMs to add more degrees that I can take over a particular fiber connectivity across there. So line systems become a big part as well, continue to play a big role, even all the way at the edge, right? And taking advantage of that, minus obviously any amplification or additional degrees that I need coming into the hub data center or the metro or the core infrastructure, okay? Maximizing my laneways. Mitch, next slide. So we look at this, right, and building that out. The other point to make, right, is the traffic, as I just mentioned, right? The traffic between that. In typical data center buildouts, as mentioned, right, when you're looking within that data center, most of the traffic is within the data center, right, traditionally. So as you're building out these functions, or as I mentioned before, as you surgically placed a particular application at the edge, I may not necessarily need to build out that same application across all the different COs, right? So I may have obviously other users that are trying to access this. So most traffic is what we call east-west within a data center. And typically in these data centers, massive data centers, you'll see petabytes of traffic, right? Especially these large cloud provider data centers. Same solution, not necessarily at petabyte level, maybe, right? Depending on where things progress. But you're going to have a higher density of east-west traffic between the offices, possibly, right, as you're growing this fabric out. You'll always have that north-south, of course, as well, and the demand increasing to go back to those training or centralized major data centers that have been built out, or those particular internet exchange points, or the particular cloud solution where that host application may be also residing from a core standpoint. So you're always going to have that north-south, and of course, south being to the end user here. But at the end of the day, we're trying to address the proximity to the end user, as well as this high availability fabric CO infrastructure. Okay. The next slide. Which brings us to this point, right? What are the four options in providing interconnectivity across those COs, or now data centers, across there, right? And you can break it into these four as I'm illustrating here, right? So larger distances, less fiber connectivity, right? Then you're trying to maximize capacity and maximize lanes of channels into these different offices. So your metro to DC connectivity, longer distances, but I need higher capacity. I want to put more with less of the infrastructure, and I want to go further out from a performance point of view. Use case two, right? In these locations, as I mentioned, right, these type of data centers, there could be some data centers or COs that are allocated as storage array networks, right? So they can take advantage of one key area to provide that type of SAN infrastructure, fiber channel capability, right? With that, there's a need for encryption capability on top of also Ethernet services. So that's use case two, where we're taking advantage of fiber channel storage array network infrastructure, right? And providing encryption across the interconnectivity there. Use case three, right? Between these central offices, right? The distances are maybe a little bit greater, or maybe up to 120 kilometers, right? Between those sites. Then you're taking advantage of coherent optics, right? So less infrastructure at the network side, yet leveraging routing infrastructure, packet-oriented infrastructure over coherent optics or IP over DWDM. Right now you're looking at 400 gig, 100 gig, and soon even 800 gig capacities over DCO optics on these routing platforms between these distances of less than 120 kilometers. Now, within the closer proximity, right, these different COs that are within 80 kilometers or less, take advantage of gray optics that are available on the market today for these longer reach to shorter reach distances that we could take advantage of in leveraging the resources that are there. That can still, as I said earlier, take advantage of mini OLSs, right? Depending on how many fiber pairs are between these, leveraging that legacy ring or hub and spoke, SONET, what was that infrastructure before, converting over to now a packet-based solution. And obviously then maximizing how many degrees that I can potentially put across there if I am still limited on fiber connectivity, right? Because the main difference on these offices compared to a data center campus, these new data center campuses that are coming out, there are thousands of pairs of fibers that are being put out there. You don't necessarily have thousands of pairs of fibers that are there between central offices. So there's where leveraging multiple degree solutions with these mini OLS systems can still play a big role. And then, of course, taking advantage of these lower cost gray optics on a routing infrastructure plays a big part of that. Okay, so the four main use cases. So moving on to the next slide. I just wanted to summarize. Obviously, with Ribbon, I've talked about the capabilities that are there from not only a voice infrastructure in freeing up that space to help realize any type of compute resources at these locations, but also from a networking point of view. So from a networking point of view, I'm not showing it on this particular slide. There's also routing infrastructure that's here at Ribbon. But a big part of our emphasis is also on our optical infrastructure to maximize capacity, provide density, provide performance capabilities across this with some of the new platforms that are there. The 9408, there is a link post-webinar that you can access through the slide deck that'll be sent out to look at a little bit more detail of a disaggregated solution with regards to a dedicated transceiver shelf that provides both that capacity and density, right, to performance capabilities that are there. Another part of that, as I talked about earlier, depending on how these central offices are built out and looking at the type of encryption that I may need, not only per channel, but also on the entire line itself, right? So there are capabilities there with our classic solutions with the 9608 or our 9600 family that can provide, depending on the densities that you need, the size of ROADMs that you need with regards to the amount of degrees between these offices. So flexibility and connectivity to fiber channel for storage array networks, and also the leverage of encryption capability between these particular sites, and that modular functionality with regards to leveraging amplifiers to, of course, ROADMs that are there, to classic add drops that are necessary at these locations as well, to maximize the amount of 100 gig and even lower in some of these areas today too. but 100 gig to 400 gig add drops at the locations, and then aggregating that back up to a higher order. Okay, so as mentioned, these links are there for accessibility to the different portfolio, and we can provide more information with the routing portfolio that may be necessary between some of the shorter distance sites. Okay, next slide. Now, as Mitch was talking about earlier, right, with regards to the demand of some of these data centers that are going on and filling up the map, as you saw today, with the secondary and, of course, some of the newer locations based on power demands that are there today, there are other use cases that are being leveraged by these central offices or service providers today, right, in building it out. I know Mitch mentioned a particular power plant, right, nuclear power plant that was built in Georgia. Now you're looking at these particular service providers that are not only building out dedicated connectivity for these data centers and these locations and these rural locations, right, but providing diversity, not only of vendor equipment, but also of providers, right, providing some dedicated services, lit services possibly for primary, but also other services by other service providers of a secondary, right, so of a secondary link between these data center locations. So it becomes a new use case for those tier 3, tier 2, even still tier 1 markets that are building out interconnectivity between these newer data centers that are coming out into the market, right? So it becomes a new use case, all of them. There's a case study that we could provide on some of this type of information and the drivers of obviously leveraging 100 gig, 400 gig connectivity between these locations. Next slide, please. Now, just to kind of touch on a few things, right? We've talked about the availability of obviously the equipment capability, the roles of these data center locations, but then it becomes the experience that Ribbon can also provide into building these solutions out for you. So we've got a number of use cases that we've done with different service providers that are looking to either connect, as I shown in the previous slide, connecting these different data centers, providing diversity, connectivity diversity, equipment diversity, fiber diversity, obviously, to these locations, but also meeting the needs, as mentioned, at these different sites as we distribute the technology, distribute the application further out to the edge, to the end consumer. So 100 gig fiber channel encryption capabilities on some of these. Same thing for the data center companies themselves and providing the connectivity at these locations. The enterprise companies in these different locations, as I said, as you're building out further to the edge, as you look into these warehouse or where these particular locations where multiple companies are building out from an IoT point of view, further density need and applications closer to those businesses, as well as the capability of accessing their database information. You need to have obviously the infrastructure to be able to build that out across all these variety of different deployments in the field. So happy to share, happy to work through you with all the different experiences that we've had with these different types of customers, different types of deployments, different types of service providers that are there based on what we've learned and building that out, and also monitoring and maintaining these infrastructures as well. And then before I pass this back to Mitch, I think one more slide, Mitch, we wanted to touch on there is just trying to close it out a little bit, right? And looking at how these edge data centers are going further out, especially the edge AI applications further out to the end consumer. But just 4 main points to kind of focus on there. So data center focus for AI, right? We've talked about that with inference, putting those data models, large data models, into action. So we're going to start to see a pivot there of putting that capability further closer, right? Which is driving then the need of shorter latency capability near the end consumer, right? As we've been building that infrastructure out, all these data centers have been building that out for years. They're taking the next step and looking at now, how do I distribute my resources intelligently? Where do I want to put these key applications at these key locations rather than those data center companies building out further out, or those particular AI applications having to go with the just more regionalized data centers that are there today? How do I get closer to my end consumer based on the either business or residential demographics of the particular location, right? So how do I get a little bit more surgical there? Service providers, central offices, right? So you're seeing that classic office, right, going through a modernization capability now of having the ability to host these applications, provide data center type of fabrics, as well as the third point, distribution of these resources having a location, having classic meet-me points, having connectivity between the central offices, right? So having lower latency, having the ability to provide high availability if necessary on these hosted data center cloud solutions at each office, right? And obviously meeting the performance needs, meeting obviously the needs of power, cooling, connectivity, of course, right? And the real estate that's available. And last but not least is DCI for AI, right? As I talked about that traffic demand, you're going to see how these get distributed rather than putting the same function at every office. You'll see a distribution or intelligent distribution of the function in key areas while still providing connectivity across all those offices. So you'll see potentially a bigger demand from an east-west between the offices versus traditional, which is traditional for these office deployments, especially from a data standpoint, is north-south or back towards the core. You will see then potentially a growth in the demand of infrastructure between offices at the further edge. Okay. But as I mentioned earlier, right, and Ribbon being positioned there, obviously from an infrastructure, from obviously voice monetization, taking away some of the classic legacy devices that are there, modernizing the network infrastructure as well, right? Having the software tools to monitor, maintain, provide lifecycle management. Ribbon is at a good point that we can obviously have further discussions with you at any point and looking at this a little bit further, our solutions. Okay. So again, thank you for the time. Look forward to having deeper discussions with anyone as well next time.
Thanks so much. Thanks so much, Philip. And just wanted to kind of close this out with just to let you know, this is part of a series of webinars on DCI. And the next one Philip and I are going to do is talking about the different options for you to build your DCI network. And the one that's becoming, it's been around for a while, but it's starting to get more interesting. It's called a managed optical fiber network, or a MOFN is the term. And we'll discuss that in our next webinar. It's on Wednesday, May 14th, same time as now. And you can see the link below to register for that. So if you enjoyed today's webinar, please check out that one. So thanks so much, Philip. Great presentation as always. Couple of questions, I guess, while we're waiting. We certainly open this up to chat. So folks on the webinar, please submit your questions via the chat. But just in the meantime here, a couple of questions. One thing you mentioned was interesting, how COs have great meet-me points. I mean, they have great meet-me infrastructure they've used in the past, and that could be leveraged for AI. Can you just elaborate a little bit more on how that infrastructure will be important for AI?
No, absolutely, right. As we look at obviously the build out of not only a particular carrier, which has thousands of offices, right? You hear this carrier neutral type of data center as well. Well, when you look at these connectivity points for ILAC and CLAC infrastructure that have been put in with private cages and being able to then connect to all these different resources, that provides already a great location to provide dedicated host solutions, right, at these areas by other carriers as well to connect to those same consumers or businesses, right? So leveraging infrastructure that's been broken up, right, to provide accessibility by other carriers provides a great little meet-me point, right, for that business application as well to connect wherever I need to, right? So that's one of the first parts of it, right, is just it's already an infrastructure that's been opened up for any carrier to connect and have accessibility as well.
Yeah, I think it's a really good point, and it's really good, interesting to see how the networks that were built in the past for voice and data can be leveraged for AI. You know, so I think, like I said, it's back to kind of the valuable beachfront real estate. I think it's all things like that that make it that much more valuable. And I think just another point on AI, the big space and power you need in the core data centers to support AI, you don't really need that to do inference at the edge. You really just need, you know, racks of space and maybe some basic power. So really everything that you have in those central offices really is going to meet the needs to do inference. So yeah, I think it's
absolutely. I mean, you're distributing resources at this point, right? Like any architecture that we've looked at from even a networking point of view. These are hierarchical type of distributed networks to obtain what you need to build out, but you don't need the same amount of resourcing, or in this case, power needs, because of the distribution of now those compute resources across all these different offices. And as mentioned too, right, these AI applications, right, do not necessarily need to be at every office. So every application does not need to be there. They can be very surgically placed in particular areas, right? So you're going to see a new wave of analysis happening in these offices. Where do I need to place application X, right? Does it need to be closer to this particular area based on the type of businesses that are there, or based on the residential, accessibility to consumers there at this particular point? Where do I place it? So now I'm distributing further. That's an action that's been going on for a while, to be honest, right? In building out these different data center campuses.
Perfect. I know I see we only got a little bit more time, maybe one more question. We talked about that case study in Georgia. So could you elaborate a little bit more what role service providers with rural fiber can play for DCI?
Yeah, Mitch, do you want to take that?
Yeah, sure. I think, like I said in that example, customers want diverse fiber, right? So when you're doing a secondary DCI path, you don't want the fiber, you can't have that connection over the same fiber as your primary path, right? If you lose the fiber, you lose everything. So having diverse fiber is really key here, which is, I think, key to the Georgia service provider win. And I think many of our customers who are in rural areas, who have access to rural fiber footprint, are again, think of it as another kind of example of beachfront real estate. I think it's very attractive to provide that alternative DCI option. And I know, being on some calls with talking to some service providers, they say they really welcome having that backup DCI option. They don't want to just rely on a single vendor for connectivity.
Yeah, you hit it well there. You hit it well. It's that diversity of service provider, or diversity to what maybe they have. They may have dark fiber, of course, and they built their termination points, but you still need to provide some level of fiber diversity outside of your own infrastructure as well. I think you hit that really well. And then it's the accessibility. As you're building out these data centers, right? I agree with you, Mitch, right? There are only so many providers that have that touch or access to all of those locations in those areas, right? And it becomes another business to monetize on for service providers to build out other diverse paths.
Yeah, exactly. And like I said, even for data centers in a metro or in kind of, around a metro, that rural fiber is still very valuable, as we showed in that example. So check out that case study. We just published that case study. So I don't know if we're running out of time, but hopefully people enjoyed this session. It was a really great conversation, Philip. Like I said, if you enjoyed this one, please register for the next one on all the different ways to do DCI options, including the MOFN option. And we look forward to a great conversation. So back to you, Greg.
No, great. Thanks, Mitch, Philippe. That wraps things up for today, folks. I want to thank you all for attending. We appreciate it. We'll be sending out the follow-up email with that deck included and all those applicable links, which, of course, the Managed Optical Fiber Networks webinar on May 14th. It's going to be simple now that you're registered on the Bright Talk network. It's a single click to register and get it added to your calendar so you don't miss it. So really just a final statement of thanks to Philippe and Mitch for putting together this presentation. And that's it from Ribbon today. We'll see you next time. So have a good day.
Thank you.
Thank you.